Hi, this is the code for the 8 puzzle I have implemented using Python, and there are 3 states over here named as easy, medium and hard, and we have to obtain the gold state as here, and we have functions for executing those. And this is the function print children that prints the output in an orderly manner, like into a square. And then this print final path is a function that finds the path of the node from the goal state. And we have a class. This class has these stacks and some depth, cost and total path costs. And this is the visited state. This is a boolean function to check if the node is visited or not. And this is the constructor. We use like these constructors to find our implementation, and these are the setters and getters for the children nodes and the parent nodes. And this is the set visitor is the function that if we know if the node is visited or not. As we go on, we find the heuristic functions here. We have 3 different types of heuristic functions, and the first one is to calculate the function. This calculates is without the tiles that are outplaced, that is, if they are misplaced they won't calculate it. This is the h1, and the h2 includes the misplaced tiles. And for the A*3 search, I have constructed it as this, that current position multiplies with its own cost or value. And this is the heuristic function I have constructed, and there are potentially just 4 moves that are going to make up, like up, down, left and right. Those are the actions, and according to it we can split it to 4 children's, and these are that. And there are actually 8 states, 8 states where the position can be filled and empty space, so totally 9 states. So for 9 different states we fill the actions and childs, how they work, and these are that. It goes on. So with those 4 potential moves we can construct it for the actions, the keys and the depth and the cost of it in this function. So we are going to implement this in a queue or a stack. I used queues for something and stack for something, and then we have to sort the queue. So for sorting the queue we use this function, and this is the class queue and this is the class stack. We can also use this with a dictionary for that. And then for A* search we need the check replace visited nodes and check visited nodes, these functions. And for uniform cost search nodes we need these 2. So the breadth first search works, as we know the algorithm, it just adds the node for checking the states and the node list. This is how they add. If this is going to print if the node state is the goal state, or else it's going to append everything or push. So the depth first search, we know the depth first algorithm as it how works, and this is how it works. This is the node. It reverses the child list as it was found wrong side of the tree. So the solution improve the result over here. And then iterative deepening, we know how does this works, and it adds a length, like we have a stage, we have uniform cost search. It calculates for using the cost of the path, and then pretty much it's the same for every search, and then we just change this part of the function. You know, the using the greedy first algorithm like this. I have also included the outputs of these functions. So this is the user interface we use here, So that's the implementation of the 8 puzzle.